Alright, in this video we're going to talk about inverse functions. So we'll start with the function. So consider the function f, and f is going to go from a to b. So it has a domain of a and a range of b. So again, I'll draw this one using a mapping diagram. Oh, I should add f must be 1-to-1. So we talked about in the previous video what a 1-to-1 function is. So f here is going to be a 1-to-1 function. So a will consist of the numbers 0, 1, 2, 3. B will be -1, 0, 1, and 2. So 1-to-1 meaning each input has one output, and each output has a unique input. So each arrow is going to a different thing. Okay. The inverse, and the way we're going to write this, the inverse of f, and the notation we use, denoted f, and we put like a little -1 up there. So it looks like f to the power of -1, but it's not. It doesn't make sense to put an exponent on a function. So f inverse, that's the way you read that. But the symbol is just f to the -1, has a domain of a, oh sorry, I just wrote that backwards, has a domain of b and a range of a. So notice it kind of flips. Instead of having the domain a and the range b, it changes its domain is b and its range is a. So it switches the domain and range, and the function will be defined as follows. It is defined as f inverse of y, so whatever number from here will equal x if and only if f at x was equal to y. So we can kind of think about f inverse doing is basically the opposite of f. So if f took x to y, then f inverse would take y back to x. So this one here was f. So if we wanted to, for this example, do a mapping diagram of f inverse, I'll keep the sets on the same side. So I'm still going to write b over here. So -1, 0, 1, 2. And then set a will be over here. 0, 1, 2, 3. But in this case, the arrows are going to go in this direction, from b to a. So a took 0 to -1, so b is going to take -1 back to 0. Same thing, 1 to 0, 0 goes back to 1, 2 went to 1, so 1 will take 2, go back to 2, 3 went to 2 up here, so 2 will go back to 3. So f inverse just goes from b back to a, and it does so taking each element sort of back to its original, back to where it started, under f. Okay, so that's what an inverse is. One thing you might be asking is, why did f, this might be obvious to you, but why did f have to be 1-to-1? So I said f must be 1-to-1. Well, think about a function that is not one-to-one. So consider, let's call this new function. Consider g, which goes from a to b. And g won't be one-to-one, so it's, not very creative, so I'll use good old set 1, 2, 3, 4. But b is only going to have two elements, let's say 5 and 6. So g is going to take 1 to 5 and 2 to 5, 3 to 6, and 4 to 6. So in this case, the inverse of g would not be a function. And sort of to see that, it's not too hard to see that, right? If you just rewrite these two sets. So this was g. So b, a. So the inverse, 1 went to 5, so 5 would have to go back to 1, but 2 also went to 5, so 5 would have to go to 2 also. And similarly, 3 and 4 both went to 6, so 6 would have to go to 4, or 3 and 4. So each input, right, these are now the inputs. What was the outputs become the inputs, so under the inverse, so each output, each input does not have a unique output, and that's because the original function g was not one-to-one, right? A one-to-one function means each output also has a unique input, and if we reverse the roles of the inputs and outputs, that would mean the inputs under the inverse would not have unique outputs. This still does have an inverse, right? This is the inverse. It's this relationship here, right? You can still draw the mapping diagram, but that inverse is not a function. It's only what we call a relation. So we can't use this notation of, you couldn't write g inverse, so what looked like, this notation here, kind of look like g to the negative 1. It wasn't to the negative 1, it's not an exponent, but you can't write this. So we can't write this. We can't use this function notation if it's not a function. So you're not allowed to use that notation. But it still is an inverse. Okay. So the inverse of f, so the inverse, maybe even I should add that to the definition, the inverse function of f. So if you want to put that into your definition, f inverse has a domain of b and a range of a, and it's defined as follows. So that only works, this function definition only works for one-to-one functions. You can still talk about inverses of non-one-to-one functions, but they're not functions. And generally in this course, and generally we talk about functions. It's called advanced functions. So we're not going to talk too much about inverses that aren't functions, but you should still be aware that they exist, and you should be aware when they'll occur and which